When comparing and ordering integers, it's important to make sure that you understand what makes a number smaller or bigger than another number. So if we look at the number line, any numbers that are on the right-hand side of the number line are going to be bigger than numbers that are on the left-hand side of the number line. Also, the way the number line is numbered is that the smaller numbers are always over here on the left, and the bigger numbers are on the right. And the further you get on the right, the bigger they get, and the further you get on the left, the smaller they get. With integers, negative numbers are always going to be smaller than positive, and the bigger a negative number gets, the smaller the value. You can think about it with money. So if, for example, I have $10 and you have $3, obviously I have more money than you do. But if I owe $10 and you owe $3, I actually have less money than you do because I have to come up with $10 just to get to zero. You have to only come up with $3 to get to zero. So you can see on the number line that I would have to go all the way here. I'd have to come up with all that much to hit zero. You only have to come up with this much to hit zero. So negative 10 is actually a much smaller amount than negative 3. Again, if you're looking on your number line, as we read this way, the numbers get bigger. So negative 3 is bigger than negative 10. There's a lot of ways to look at that. So let's do a little bit of comparison using greater than, less than, or equal to. So negative 4 and negative 7, which one do you think would be bigger? Negative 4 or negative 7? We can look at the number line if we need to. So if you thought negative 4 would be the bigger number, you're correct, because negative 4 is further this way than negative 7 is. So we're going to put a greater than symbol. The wide open end always faces the bigger number, and the tiny closed end always faces the smaller number when we're trying to figure out which symbol to use. And then we read from left to right. This is left, this is right, so we read greater than first. If it was this way, we'd read the less than side first. Now let's look at 5 and negative 5. Which one of these do you think is bigger? So here's 5, and here's negative 5. Well, negative 5 is on the smaller side of our number line, or you can think about it as the further we get towards the right, the bigger the number is. So 5 is our bigger number here. So again, we're going to use a greater than symbol. And what about negative 10 and negative 3? Which one of those do you think is bigger? Well, negative 3 is here, negative 10 is here, and that's just like the example I gave with owing money. So negative 3 is actually the bigger number, and negative 10 is the smaller, so put a less than symbol. Next, we're going to put some integers in order from smallest to largest. So we want to figure out what number comes first. On the number line, we can actually look up here to help us out. We have negative 2, we have a negative 5, we have a 6, and we have a positive 2. And we can easily see the order that the numbers will be in. Negative 5 is the smallest, then negative 2, then 2, then 6. So take a second, pause the video, and try this next problem. This one's a little harder because it has decimals and fractions. And so you will want to convert your fractions to decimals or your decimals to fractions to help you out. So the first thing I did was I converted all fractions to decimals because they were pretty easy to convert. And now I can really compare. So I can see that I have these three as negative numbers. So I need to start there first. Those are my smaller numbers. And negative 0.4 is going to be my smallest. Then I have negative 0.3 repeating. Then negative 0.2. Next I have my positive numbers. 0.5 or 5/10, and 3.9 or 3 1/10. 0.5 or 5/10 is the next smallest, and then I have 3 1/10. Now we're going to try some advanced absolute value problems where you really have to understand absolute value in order to solve these. In our first problem, we have the absolute value of some number n is equal to 2, and we want to figure out what number or numbers could replace n. And what I want you to keep in mind here is that this number 2 is the actual absolute value. In other words, that's the distance from 0 to the number. So that's the distance from 0 to n, whatever our n will be. So let's think for a second. If we know our distance from 0 to n is 2, well, here's the distance of 2 right there. Can you think of anywhere else where we might have a distance of 2? If you thought from 0 to negative 2 might give you a distance of 2 as well, you're correct. So n can actually be, or actually is, negative 2 as well as 2. So you can replace, and you can check this so that it makes sense to you. We can put in negative 2 in the place of n and see if that gives you 2. Does that make sense? Is the absolute value of negative 2 2? Sure, because the distance from 0 to negative 2 is indeed 2. Then we can substitute positive 2 in the place of n and see if that makes sense. Does the absolute value of 2, positive 2, also give you 2? Well, sure. If I go from 0 over to positive 2, that is also a distance of 2. Therefore, n could be negative 2 or 2. Either one of those will make this a true statement, so that's our answer. So, the important thing to keep in mind, once again, is that 2, right here, the number on the that everything's equal to, the number that everything's equal to, is the absolute value or distance. N are the numbers on the number line. So 2 and negative 2 are the numbers on the number line. Those are the numbers or the values of n. So let's try the next problem. See if you can think through what the absolute value of n could equal if the distance is 8 this time. So this time the distance is 8. So if you know for sure that n has to be at least 8, you're on the right track there because the distance from 0 to 8 is 8. Now if you're thinking to yourself, well, I bet the distance from 0 to negative 8 is also 8, then you're on the right track there as well. Because we can count over 8 in the negative direction and get a distance of 8. Therefore, n is both 8 and negative 8. 200. Now, we're not going to use the number line for this, obviously. So I want you to just think about, based on what we figured out for these previous two problems, I want you to think about what you think the answer or answers would be for this problem. If you decided that n could equal both negative 200 and positive 200, because both of those will give you an absolute value of 200, then you are correct. After you practice a couple of problems. So pause the video now and try these next 3 problems. So the first example, we should have negative 5 and 5 because both of those numbers will give us an absolute value or distance of 5. For the next one, we should have negative 9 and 9 because both of those will give us an absolute value of 9. And then for the last one, we should have negative 22 and 22 because once again, both of those will give us an absolute value of 22. So now that we understand this, let's move on to some harder problems and see what your brain can take. So in this next problem, we have an inequality. In other words, instead of having an equals mark, we have a less than mark. A less than, greater than, less than or equal to, greater than or equal to, or not equals to are all considered inequalities. So here, we want to figure out what values will make this a true statement. What can I put in the place of n such that we get an absolute value less than 2? So let's think about this for a second. We know that this is going to be the number of numbers on the number line. We know that 2 is the absolute value or distance. We're looking for all distances on our number line that are going to be less than 2. So think about that for a second. 2 would not be included because that distance is 2, which is not less than 2. But what do you think would be included? You've got 1, you're correct. A distance of 1 would definitely be included. So let's think about all the numbers that would give us a distance of 1. Well, if you're thinking 1 would give us a distance of 1, you're correct. Anything else? If you're thinking negative 1, you're also correct. Now, are there any other distances that would be less than 1? How about 0? So your answer would be 1, negative 1, and 0. And we can check it to make sure it makes sense. So the absolute value of 1 is less than 2. Well, the absolute value of 1 is 1, and 1 is indeed less than 2, so that works. The absolute value of negative 1 is less than 2. The absolute value of negative 1 is 1, and that is less than 2, so that works. The absolute value of 0 is less than 2. Well, the absolute value of 0 is 0, and that indeed is less than 2. So let's move on to our next couple of problems. So in the next one, we have absolute value is less than or equal to 1. So let's look back up here on a diagram. So we have a distance that's less than or equal to 1. So here's 1, and here's another distance of 1. Does this look like anything that we thought about before? It's actually the exact same thing as the previous problem because anything that's less than or equal to 1 is also less than 2 in these examples. So again, we would have n equaling 1 and negative 1 because both of those give you an absolute value of 1, and then 0 because 0 gives you a distance less than 1. And then the last problem we have the absolute value of n is less than 4. So in this problem, if it's less than 4, here's 4, so it has to be less than that. So we're going to have a distance that is 3 or less. So we have to think of all numbers that will give us a distance of 3 or less. So we're going to have 3 and its opposite, 2 and its opposite, 1 and its opposite. And don't forget 0. So n could be any of these. Any of these would make this a true statement. Take a second and check that and make sure it makes sense to you. This is the end of the last video, video 3 on Introduction to Integers.